Okay, here we go. This is AP Computer Science A, and I am Rob Schultz. I teach at Bellbrook High School. And I'm from Bellbrook,
Jill.
Ohio. Sorry,
Yeah,
lost
no,
my train of thought there for a second.
that's okay. And I'm Jill Westerlund from Hoover High School in Hoover, Alabama. We're so glad that you're with us. I'm going to assume everybody's here every day and that you already know all about our community of learners all over the map. If today's your first day, welcome. You got some videos to watch because we want you to go back and watch every video we've made. Okay, so the test that we're working toward is on May the 15th, and you're going to have 2 questions, either an array or an array list question, and then question 2 will be a methods and control structures question. Today we are working day 4 of array list week, and you're going to see things that relate to both of these questions. So here's our schedule. And today we are back to card game and card decks, and we're going to show you a variety of things that you can do using array lists of cards. And we're hoping to get you engaged in writing some code in Java to sharpen your skills toward being prepared for those 2 questions that you'll see on May the 15th. All right, we are trying to get you to take some notes. You know that you're going to be having an open notes, open book exam. So now's the time for you to begin to prepare toward that. There are resources toward that. You are going to need paper and pencil today, and we'll remind you of that again. But before you write code on the computer, we would love for you to spend a little bit of time writing code on paper and wrapping your brain around the concepts that the algorithms need and the structure of the code and the design. So for the warm-up today, we're going to be doing tile games. So Mr. Schultz is going to explain, and I'm going to demo a little bit.
Okay, so yesterday we started the tile game. If by some chance you haven't printed a copy off, or if you have excuse me, haven't seen part A, I would back up a little bit, go to yesterday's lesson. If you need a copy of it and you have access to a printer, if you happen to be watching this as a recorded lesson, now might be a good time to pause and go out and print. We've got the link for you on the screen to this specific question, and you specifically want pages 9 through 12. Got something in my throat. If you think about the way the question works, yesterday we kind of worked our way through what a tile is, how the tiles are laid out. We've got a number tile class that represents one of these 4-sided tiles. We have a method that will let us rotate. So this shows what happens when we take a tile and rotate it. The value that's on the left moves to the top, and the value that's on the bottom moves to the left, and so on. And Mrs. Westerlund kind of gave an example of what it means when it says clockwise for those that aren't familiar with analog clocks and the clocks with hands if you've used a digital clock. So clockwise means that we're rotating around to the right. Okay. We have a method called getLeft that returns the value on the left-hand side of the tile, and we have a method called getRight that returns the right-hand value on the tile. And yesterday we walked through this first method, getIndexForFit. So now we're moving on to part B. And part B, we are allowed to assume that this getIndexForFit method works, even if by some chance we didn't code it correctly. For insert tile, we're now allowed to assume that it works the way it's supposed to. So the goal for part B, we want to determine where a tile can be placed on the board so that it satisfies the pattern of left side and right side matching numbers. The directive that we have says that we must use part A, getIndexForFit method, which will check for matches on the left and right. And there's a little hint that goes with it that we can use the given rotate method to rotate the tile to check all possibilities. In fact, it specifically says in the problem statement that we need to be able to do that. So I'm going to pass the baton.
Yeah.
If you want to take control of the screen, and then we can look through a quick example. And then I've got some code that I can show you.
All right, so what I've done is set up the tiles that I made out of little squares of colored paper. I set them up to look like the bottom of page, well, the bottom of the beginning of the question. So if you happen to have printed the question and you're looking at the question, I've set it up like the bottom of page 9 from the free response question. And remember, we talked about yesterday that this is a spin-off of a dominoes type game, a game that would have numbers that the numbers need to match. So what the question for part B is asking is obviously where could this tile go? Let's just say this is the tile that we're interested in. And if you remember yesterday, it first checks the beginning, and if it can go there, it actually could go there in this instance. But for part B, we're supposed to write a method that will try to see where it could be inserted, even if it involves rotating. And here's my example that I gave you yesterday. If we rotate this to the right, actually, if we rotate this, let's see if I got, here's our beginning spot. So if we rotate this to the, am I doing this wrong? What am I doing?
No, I think you're okay.
Am I okay?
Yeah.
If I'm one of these is off if I rotate. I thought I wrote myself a note. If I rotate it twice, maybe. But anyway, so we got to check the rotate. So I did those in backwards order. But anyway, so part B. You want me to write?
Sure.
Okay.
Okay, so the idea for part B is, again, we're assuming that the method that we did yesterday works correctly. So first thing we're going to do is we're going to call the method that we created yesterday, the
I'm going to white this
get
out.
index for fit. And we're going to store the location that it gives us in a variable.
So here's the header that we're given for part B. I don't really know why that's there. I guess people just wrote around it in the normal thing. So we first need to get an index so that we know.
Okay, so once we call get index for fit, it's going to go through and it's going to do the check with its current orientation. It's going to check to make sure that, all of the things we said yesterday. It's going to check the size of the board. It's going to check to see if it'll go at the front, anywhere in the middle, or in the back. If by some chance it fits, it's going to return a value, which is great. But if it doesn't, it's going to return -1. So what we're going to end up doing, we also want to, because there are 4 different ways I could rotate it, we need a variable that's going to keep track of how many times we've tested, because we're going to have to test it 4 times, 1 for each orientation. Okay, so the next thing we need is a variable that we're going to keep track of the number of tests. And we can just call it test or num tests or whatever. Okay, and then because we have to test 4 times, okay, we're going to create a little while loop that says while index.
Well, this should probably be a 1 then, so it's not as confusing. We don't have to count.
Oh, that'll work.
We're in an array. Yeah. Okay.
Yeah. So while index equals -1, in other words, in that very first line, if it gives us -1, it didn't find anything with the current orientation, we need to go through and do a second. If it does give us a value, we'll just skip the while loop and we'll deal with that in a second. Okay. So while index equals -1 and num tests is less than 4, okay, then we're going to go into this loop. And the first thing we're going to do is we're going to call the rotate method for the tile, because now we want to turn it so that it has a new orientation. So we can just say tile.rotate. And once we've done that, then we're going to say, okay, well, now let's set index equal to get index for fit of that tile. So we're basically going to say, we've rotated it. Now try it again. Okay, and because this is our second test, we have to increment num tests. So this will be considered test 2. And that's the end of our while loop. Okay, so if you think about how this is going to work, we're going to hold it in its first orientation. If it doesn't come back with a response, in other words, it gives us -1, we're going to rotate it, check it again. And if that comes back with a -1, we're going to rotate it, check it again. So that'll be num tests equal to 3. And then we're going to, if that gives us no response, we're going to rotate it, check it again, and that'll be num tests equal 4. And then at that point, even if it hasn't found anything, index equals num1, num tests will equal 4, because we will have gone through this all 4 orientations. We'll jump out of the while loop. So now we have to put our little if statement at the bottom. So if by some chance index has not been -1, in other words, it found something somewhere in one of those tests, it gave us anything but -1, this is where we can add the tile to our board. So board.add index, comma, tile. So wherever it found, whatever index position it gave us that tile will fit, we're going to put it in that spot. And then the last thing we need to do is, because we have to return a Boolean value, we're going to return, oops, lost it, there it was. We're going to return whatever we get from the Boolean comparison, index is not equal to -1.
Oh, from that one, yeah.
So if index is not equal to -1, we'll return true because that's a true statement. If index does equal -1, then that condition becomes false and we return a false statement. And there is our entire insert tile method.
Yeah, and if you remember yesterday, if you watched that one, or if you go back, part A was 6 points. Part B, this portion was 3 points of this problem. So this is quite 2009. This is a pretty old problem,
Yeah.
but we liked it because it went along with our game theme. And I think I made this tile, well, maybe this one right here that didn't fit so well.
Oh, there we go.
Yeah, that's my one that I felt like was a little bit more, it would fit after it gets rotated.
Yeah.
It could line up over here now. Here's another one that has to rotate a whole bunch of times before it's gonna, well, it actually would fit the first time. Maybe it was this version. So anyway, you get the deal. So
yeah.
So that's this problem, and I hope that it makes more sense when you see it acted out. So, and we're going to come back to some cards in a little bit. So what do you want to do next?
I think the next thing on our list,
you want me to show you the card games that we're going to talk about while I'm here? Okay.
Please, let's, since you've
Okay,
already got
so
control.
while we already have this, so so here are, I'm going to show you kind of what war would be like. We're going to talk about 2 games today, and in case you're not familiar with them, these are my MTA subway line cards I got one time on a fun trip to New York. So in the game of war, you would actually have the deck split into 2 pretty evenly, and you'll see that, and I think you might have seen that the other day in Mr. Schultz's code. And both players, so it's a 2-player game, turn over a card, and whoever's card is the larger wins. So this person would win. And then you turn over another card, and they get compared, and that person would win. Tell me if you do it differently, Mr. Schultz. Nope. And the goal of war is to end up with the most cards. I guess this one would win. Joker's always wild. My right hand is doing much better than my left.
Boy, I guess.
Apparently. He's on a streak. Okay, there's one for that one. Okay, so that would be with that type of deck of cards. And then if you were using a rook deck of cards, same deal with war. You're going to have 2 cards, higher card wins. 2 cards, higher card wins. So it's a comparison game. All right, so that's war. Now I'm going to talk about Go Fish. Go Fish is super easy to play, and you might have played it growing up. Coding it has been another story. I'm going to give you part of a Go Fish game, and here's how Go Fish works. So I would deal the cards to 4 players. I'm just going to deal these cards for right now. And let's just say that that's the first person's hand. And here I'm going to get rid of the Joker. And just pretend like we have 4 people sitting here. And you'll see in the code later on when you look at the code why it got kind of complicated for me. So if this was player 1, and you would like to sort your hand, that's another part of the coding of it, is it would be better to have a sorted hand. All right, so player 1 has more 9s than anything else. So player 1 turns to whichever player, the order that you're going in. Let's just say we're going to go clockwise. Player 1 would ask player 2, do you have any 9s? And when they say no, go fish, here's the pile. Player 1 went fishing and got this card added to their deck. So that's the premise of Go Fish. And then it would be player 2's turn. Player 2 doesn't have any matches, so they could ask for anything from player 3. And I've pulled a method that we talked about a couple weeks ago with arrays. You remember we talked about those 12 algorithms that you need to know in this course? and it fit really nicely with Go Fish. I dropped a card. Hang on a second. So in a rook situation, I'm not going to lay it all out again, but same deal. I wrote my game out of rook cards with the 4 colors and the 4 ways. So I'll give you 2 players of Go Fish. Same thing would happen. This could be player 2, since that person has 2 14s. They would maybe ask the next player for a 14, and if they don't have one, that person would draw from the pile. So those are the 2 games that we're going to talk about. I also built a little math is fun game for y'all, and you can go ahead and be grabbing the screen back, and I'll talk
Okay.
while we're doing that. I wrote a little math is fun game, and I found a couple resources online for elementary school teacher to use to teach math with card games. And you may have grown up with an elementary teacher who let you play card games in the classroom. If that's a fun, fond memory for you, go back and think about those games that your elementary teacher did and build a Java program about it. We're going to give you some of the components that you need, and it'll sharpen your skills. So, all right, go ahead.
Okay, as Mrs. Westerland said, we're looking specifically at card games today, and we're going to show the code for a couple, or at least partial code and complete code for the ones we've got. Okay, so prior knowledge, use of arrays and array lists in Java, familiarity with the Java quick reference methods, and all that good stuff. So if you're not quite comfortable with that yet, I would go back and watch some of the prior videos. Today we're going to learn algorithms that manipulate array lists. We're going to use if statements in algorithm development, and you'll see some while loops in here too, and then we'll focus a little more on while loops again tomorrow. So think about the implementations for a card object. Okay, we're going to use our card deck that we talked about on Tuesday in some Java-based games. So the things we have to kind of think about as we start putting these algorithms and games together are things like, what's the goal of the game? What can be the number of players? Is there a minimum or a maximum? Is there a required amount? Do we have to have 4 players? Could we play with 3 players? Could we play with 2 players? Could we play with 6 players? How will we deal the hands to each player? How many specific cards will we have? How will the source code files interact? I mean, these are all different things that we have to think about as we start planning all this out. And again, I'm going to stress the fact, and if my students are watching, Mr. Schultz's students are rolling their eyes right now going, okay, here we go, here it comes. Make sure you take some time to lay out some pseudocode so you have a little map to work with, so that you're addressing all these questions on paper before you just sit down and start banging away at the keyboard. Okay. So you're probably going to want to get a little bit of paper and pencil if you haven't already. We've already kind of talked about the 2 games that we're going to look at. Go Fish, which is to make the most matches of 4 cards with the same number. Each 4-card set is called a book. And in War, the goal is to accumulate the most cards after face-offs, where all the players lay down their next card with the highest card value. And I want to stress, at least on the War game, War is one of those games that if you're playing with real cards, it takes forever. It's the ultimate game of boredom. Okay, I mean, when you get bored to the point that, hey, let's play War, that means you're bored. Okay, so to actually try and play a game where the users have to interact with the keyboard, it would take a long time. So our goal with War, when I do this project with my students, there's usually some question we're trying to answer. How many comparisons does it take to get from the start of a game of War to the end? If I were to play 100 games of War in a row, what would be the average number of comparisons? Or how many times do we actually have a war where the players have matching cards and they have to kind of go to battle to figure out who's going to get the cards? So we do it more as a simulation than we do an actual game. So that's what you're going to see when we do War today. Did you want to do Go Fish first, or should I go ahead and do War while I've got it?
You go ahead.
Okay. All right. So I'm going to change the share, and I'm going to jump over to JGrasp. Where's my JGrasp? There it is. Okay. And again, notice that I've got, the card object that we talked about, or I should say the card class that we talked about on Tuesday. We're gonna reuse that again. So my card, this class defines the properties and behavior of a single card object. So we've got a suit, we've got a value, we've got a constructor that sets them when I create the card. We can get the value, we can get the suit, and we have a little toString. And then I went ahead, again, because I figured we might be kind of short for time today, I went ahead and kind of preset some of this. So you'll notice that the things we talked about on Tuesday I've already got preset. I've already got the code in here that'll create a deck of cards. We'll come back and talk about that in a second because this one's going to be a little different. I've got a basic shuffle method that's going to take, if you remember when we talked about this before, our basic shuffle said I was just going to randomly take a card from somewhere in the deck and then put it on top. And I'm going to repeat that 10,000 times. So 10,000 times, I'm going to randomly pick a card from the deck and put it on top. We're going to create 2 other array lists, one for player 1's hand and one for player 2's hand. And then we've got our little algorithm that'll let us deal the cards by checking to see whether the size of the deck is odd or even. I've got all my pseudocode in here just so I didn't forget anything. And then down at the bottom, we've got our display deck little static method that I can pass a hand into or I can pass the deck into, and we can look, it's going to traverse the array list and show me all the cards that are in that particular array list. So the one thing I wanted to point out up here at the top, what we've run into in my class when we do this project, if you use an even number of cards, and you don't randomize the way the cards are played. I mean, if your algorithm always says player 1, player 2, and then player 1 gets added, player 2 gets added, and then player 1 goes, player 2 goes, and then player 1's card, if you constantly keep that, you're going to find that a large number of the times that you run the simulation, because of the cards going in the exact same pattern every time, it's interesting that you go into an infinite loop. It just continues to play the same cards over and over and over against each other. So a couple ways we found in class to deal with that would be, first, when you think about how you play with cards, there's actually some randomization to it. The cards go into a pile. It's not always player 1's card and then player's 2 cards. Sometimes it's the other way around. And so there's a little bit of randomization built into it. So we can use random numbers to decide which cards we play in what order. But the other thing we've done is we resolve that problem by making sure we've got an odd number of cards. And that way things are never equal. There's always an offset somewhere. So in this game, we're going to have 5 suits. We've got a red suit, green suit, blue suit, yellow suit, and purple suit. So this is kind of like our extended rook deck, okay? And we're going to say that each suit has 13 cards. So we're going to go from 1 to 13, all right? So let's go ahead and run it at this point and see exactly what we've got. So once I run, we're going to display the new deck. So here's my 1 through 13 of reds, greens, blues, yellows, purples, and then we display the shuffled deck after doing our 10,000 random shuffles. Looks like our deck is pretty well shuffled. And I didn't put anything to display player 1's hand, but at this point, player 1's hand and player 2's hand have been dealt. So let's go ahead and start working our way through the pseudocode and start figuring out how the game's going to work. Like I said, one of the things that we do when we simulate is we want to see how many comparisons we're going to have and how many wars we're going to have. So I'm going to start by creating a couple of variables up here. Int comp counter equals 0. So that's our comparison counter. And we're going to do int war counter equals 0. And I'm kind of breaking the rules. That should be, we'll go ahead and make it lowercase so that we're following naming conventions. Okay, so we've got our war counter and we've got our comparison counter. If you think about the way the game works, we want this loop to repeat. We want the game to go on and on and on as long as both players have cards in their hand. The game ends when one player is out of cards. So we're going to go in here and set up our while loop to say while p1 hand.size is greater than 0 and p2 hand.size is greater than 0. So as long as they both have at least a card, then we're ready to go with this thing, okay? When we go to play, what's going to happen is player 1 is going to flip their card, player 2 is going to take a card, and then both players are going to show their cards. So we're going to deal with that part next. Okay, so card, P1 card equals new card. Whoops, I'm not getting a card. What do I want to do here? P1 hand, I almost forgot what I was doing. Remove 0. So we're going to take the top card off the deck, and then card, P2 card equals P2 hand dot remove. Okay, so now each player has physically removed the card from the top of their deck and they're holding them separate, and we're going to display them. We'll just say system.out.println P1 card plus, we'll say versus P2 card. I can't type, there we go. Okay,
You need a
So,
semicolon at the end of 46, by the way. People at home might be screaming that.
thank you.
Say it, say it, say it.
It is
There you
so
go.
nice to have a second set of eyes when I'm doing this stuff. Okay, so now that we've done that, we're going to do our comparison. We're going to see which card is higher. And because we're counting the number of comparisons, this is where we're going to do comp counter plus plus. So we're going to add one to our comparison counter. And we need to start looking at the different possibilities. We've got 3 different outcomes. We've got the outcome where player 1's card is a higher value than player 2. We've got the outcome where player 2's card is a higher value than player 1, and then we've got the outcome where they're equal. So we'll deal with player 1's first. So if P1 card.getValue, so this is where we use that getValue method, is greater than P2 card.getValue, that means player 1's card was higher. We're going to say that both cards are added to player 1's hand. Now, if we were using an even number of cards to avoid that issue of infinite loops that I was talking about, we would want to throw in some kind of a randomization here to get a random number and then use the random number to decide which card we were going to put into the deck first. But for the sake of time, we're just going to say that both cards get added to player 1's hand at the bottom, and we're going to just go ahead and take player 1's card first. So P1 hand.add P1 card, and P1 hand.add P2 card. So we're going to just take them in that order, put them right onto the back of the deck. Okay. Else if, because we've got 3 choices, so else if P2 card dot get value is greater than P1 card dot get value. Yep, there we go. Almost forgot that second parenthesis again. Then we're going to add the cards to player 2's hand. So P2 hand dot add. And we'll say that if player 2 wins, then we'll take player 2's card first, and we'll take player 1's card second. Okay, if player 1's card isn't higher and player 2's card isn't higher, then the only other possible outcome is that they're the same. Okay, so I'm going to move my camera down a little bit just so I can show you what we would normally have happen. I'll move down a little lower. Okay, so I've got my little cards here. So if by some chance player 1 and player 2, so this is where we would have an actual war. I'm going to cheat and say we have a war. I don't have any kings in that side. There we go. So let's say player 1 and player 2 both turn over the same card. Okay, they both turn over kings. The way you would typically handle this is now you have to create another array list. So player 2 is going to take 2 cards, player 1 is going to take 2 cards, and then they both flip again. And if these happen to be a match, then you take 2 more cards and you flip again, and all of these cards then collectively get handed to the winner. Again, to kind of simplify this lab just a little bit, we're going to treat a war a little different. Okay, and I'm going to kind of challenge you to make this part of your homework assignment tonight, if you would like to go through. Let me get rid of some of my comments here. There we go.
Oh, tip your camera back up.
Oh, thank you.
There you go.
Okay, there we go.
Hi.
Hi there. So what we're going to do is we're going to handle this a little bit different. Okay, we're just going to basically pick a random number. We're going to use math.random to give us a number between 0 and 1. If by some chance the random number is less than 0.5, then we're going to add the cards to player 1's hand. And if the cards are greater than 0.5, we're going to add the cards to player 2's hand. So that's how we'll kind of randomize that a little bit. But if you really, really wanted to make this like the game of war, then we would have to modify what goes on inside this else statement a little bit so that we get this extra array list and we add all the extra cards to it. And I was afraid that we were going to run out of time because we still have Go Fish to go through. So I'm going to leave that one to you to kind of look at on your own. So we're going to declare a war. So system.out.println. We're going to say war, just so it shows up as we're playing this thing. We're going to add 1 to our war counter. So war, what did I call it? War counter. Okay, and then we're going to pick our random number, and we're going to say int who gets it equals math.random, and we'll just do that. We don't have to do anything fancy. So if who gets it is less than 0.5, then we're going to give the cards to player one. So P1 hand.add P1 card, P1 hand.add P2 card. Else P2 hand.add, and we said if player 2 won, then player 2 picked his or her own card up first. P2 hand.add P1 card. Okay, and let's see, that's the end of our else, and that should be the end of our loop. So I want to make sure I got this in the right spot there, and we'll do a quick check, make sure I'm closing off the right one. Yep. Okay. So now that we've gone through this whole loop, that's everything that's going to happen inside the loop. And as the only time we should jump out of the loop is if one player runs out of all their cards. Once we jump out of the loop, then we're going to display the results. So we're going to display 4 different things. We're going to display the number of cards remaining for player 1. Player 1. P1 hand.size cards remaining, and we'll display the number of cards player 2 has. I should do better about copy pasting. It would be faster, but
you're a really good typer.
Kind of get into a groove. You know, I tell my students that one of the most beneficial classes that I took in high school was typing with Mrs. Mrs. Sanderson. I almost forgot her name. That's horrible.
Mrs. QWERTY Keyboard.
Mrs. QWERTY Keyboard?
If you forgot her name.
Oh, yeah, there you go. But I remember we would race down the hall because she had like 5 electric typewriters that would go really fast, and all the rest were those old manual typewriters.
Oh my gosh.
But between that and 12 years of piano lessons, I can type. Let's see, comparison, count. What I can't do is talk and type at the same time. I can't multitask. So we'll get our comparison count, and then we'll get our war count. System.out.println war count. Yeah, Mrs. Schultz will tell you that I can't multitask. Okay, that should be the whole thing. And if, fingers crossed, there were no typos, which I'm sure there probably were, we'll go ahead and compile and see what we get. I knew it.
Or counter. It's
yeah,
counter and counter.
Okay, so let's see. Where do I want to be?
I don't know about that one.
Oh, I need to convert it to an int.
Declared an int, yeah.
Yep. Okay, so we'll fix that. Yeah, now we'll just kind of work our way through and fix all these little guys.
ER.
We'll try again.
That'll do it.
Take care of all of them. Yep, that's it.
Let her rip.
Oh, wait.
What?
No, I can't make that an int because then it's always going to be 0. We want this.
Gonna have to make it what?
Be double. There we go.
Double.
Okay.
You get to keep it then.
Yeah. So in case I did that really quick, math.random returns a double value. Okay, I was assigning it to an integer variable, which Java does not like. It's the whole bucket size thing. Remember early on we talked about an int's a 4-byte bucket and a double's an 8-byte bucket. They're kind of like measuring cups. You can't pour 8 bytes into 4 bytes. So when I would have declared that as an int, math.random, because it's always 0 up to but not including 1, it would have given me 0 every time, which meant that it always would have gone to player 1. So we need to set that to a double.
Well, if you wanted to stack your game because you were player 1, then
that's true. We could stack the game.
But we're not about that.
Okay, so I'm going to clear our run, and then we're going to run it and see what happens. Okay, so here's the game playing out. Ooh, we're getting that infinite loop thing again. I thought we would have resolved that.
Who will win?
Oh, we're getting the infinite loop.
Wonder why?
I don't know. We shouldn't. Let's see. I'm going to stop it, and then we'll
Is it rebuilding the deck again and again?
No.
Maybe no.
That is so bizarre. Why is it doing that? I missed something somewhere. What did I do different this time? Because that
I had it happen to me yesterday, and thankfully JGrasp has the end button down there.
Yeah. We're not actually getting to the end.
But
that's really strange.
I had to deal with my deck. It kept redoing the deck again and again because the deck was continually getting called. Mine was a deck issue.
Hmm.
So
That's
y'all, if you're at
interesting.
home and this happens to you, we're just like you.
Well,
Some
let's try this.
days,
Let's make sure that we're giving the cards. Maybe that's what I did different. Maybe I always gave player 1, player 2. So let's adjust that a little bit. Okay.
It's going to be interesting if that fixes it.
That seemed to fix it. Yeah. Okay.
Oh
So we
my
had,
goodness.
that's really weird. Okay. So this would be where, as a programmer, we would sit down and start kind of looking through our code to go, okay, why does that really make a difference? And maybe to do some testing, because this is the topic for tomorrow, maybe we would take this and shut it so that instead of, I think, what do we have, 75 cards? Maybe we get rid of several of these decks. Or different suits.
Test
So
it
we
with
just do
smaller
13
batches.
cards. So we do it with
Yeah.
smaller batches, and then we add some extra little system that prints, because that's really kind of an interesting problem that I didn't anticipate it would do. But the point is, now we can run it over and over again. This time it had 328 comparisons with 24 wars. And we can back up and actually see the whole game play out. So we had a 10 of purples versus a 10 of yellows. So we declared a war, and then 3 of yellows versus 13 of yellows, and so on. And every time we run it, we're going to get something a little different. 340 comparisons, 347 comparisons.
And if you're taking AP stats, this is a secondary problem for you in that course.
Yes, good call.
Like the dice rolling scenarios in AP stats. So double bonus for you AP stats folks.
Yeah, this one was a big one. This
one
took
and
1,390.
apply it to a stats question.
Yeah. And like I said, if we wanted to continue the simulation out a little bit and say, okay, what happens when we play 10,000 games of war? We just wrap all this into another loop.
That means your plane got delayed and you were stuck at an airport and you have nothing else to do. So and you're out of time.
So that is our war game. There is
I
war.
love it.
So this is our war game simulation. If you get so bored that you would rather watch this simulation than actually play war, then I feel sorry for the situation that you're in. But
that's
in
right.
any event, this is where we could simulate, and I love the idea of pulling this for stats information. You could do some really cool stuff with that. Okay, so I'm going to pass the baton back over to you so we can talk about Go Fish.
I'm going to grab the screen and I'm going to show you what I've given you. I've already put it out in the folder for y'all to have. I've given you enough to be dangerous and enough hopefully to be inspired by. Can you see my screen?
I can. Got it.
Okay, so I renamed my card and my deck to card JW and deck JW because I thought if Mr. Schultz and I mixed our files, it was going to cause you a problem. So I used the same card class that Mr. Schultz used. My deck is very similar to his. I used the same methods that he had. So then I began to set up, and I'm going to move the space of these. The first thing that I did, and this is part of what I want to explain, is I needed to deal cards to 4 players. So after I got that going, I then determined that I needed to handle the 4 players' hand. Remember me showing you that under the camera? I needed to treat each of those array lists as also arrays. So you notice up here, I've kind of gone off to the beach on a trip out of our swimming pool of Java. I've had to bring in a couple of collection options so that I could have an array list of ArrayList. The way that I set this up, and I would love for y'all to play with this, and this is really a template for building other games. So this game setup for 4 players, I built for y'all as a template for you to build other games. And you could add 6 players, you could take it down to 2. Everything is getting called up here in the main method, and that's why I commented it. But what this does is it's going to deal cards. I'm going to run it. It's going to deal cards. I think I have it dealing like 10 cards per player to 4 different players. So it shuffles the cards with the same method that you learned on Tuesday. It builds a deck exactly like you learned on Tuesday, and then it deals the cards. So this is your template for any card game. Then I started building Go Fish, and life got infinitely more complicated as I began. So it's a lot of the same code. I just copied and pasted my code. This is where I needed an array of arrays, array list of array list. So you'll notice here in this deal to the players, I used this before. I have this array list of array list, and then I'm going to come down here quickly and show you, and y'all can play with this yourself, but player 1 needs to ask player 2, do you have any whatevers? Well, to find the whatevers, we needed to find mode. So this is where I went back to Array Week 2-3 weeks ago when we talked about those 12 algorithms that you are responsible for knowing. Those algorithms apply to both arrays and array list. And I went back and got our find mode method that we talked about a couple weeks ago. I had to change it just a little bit, but I'm going to run this Go Fish game, and you'll see that what happens is, and I'll move my screen up and make it look a little bit easier to read. After it plays, after it deals the hands, it sorts each player's hands. So I had to build a method to sort the hands in numerical order, lowest to highest, and we talked about that a couple weeks ago. That was running through to sort them, and we talked about just a couple of days ago, insertion sort. All right, then I found the mode, and player 1 then asked to player 2, do you have any ones? And if player 2 has a 1, they give it over. Now here's where I have something that's not complete that you can make this fancy and make it better. It's only given them one of their ones. In the real game of Go Fish, if you ask for ones, you got to give over all your ones. So that's kind of where I stopped. I also wanted to resort player 1's hand once player 2 gives them what they give them or they draw from the deck. So I have some commented code there. So I also built in for player 2 to ask player 3, do you have whatever they wanted? All that works. It's just I was to the point of getting ready to resort and re-ask. So you could go ahead and keep doing this, but it is going to be easier to find the mode if the list is sorted, and you're going to want them to give away all their cards. So then this morning I went to the whole math game like I told you earlier. This completely works, and I'll tell you why I like this. And it still uses some of the same imports, but it's more like that elementary school game. So it gives 2 stacks of cards, and I think I have it given 15 cards. And this is a lot more like what I think question 2 would be like for this year's exam. And this is part of why I picked this little problem to write. It really just uses selection and iteration. So I'm going to show you the code, and then we'll watch it play, and I know the clock's ticking. So here's the shuffle method that you're already familiar with, dealing each player 15 cards. And here's the math is fun method. If the player imports from the keyboard a plus sign, then they're going to practice addition. And so it's an outer for loop that's going to continue popping through 2 cards at a time, and the child is supposed to type in 1 card added to the other card. What's the sum of those 2 cards? And like I say, if you had an elementary teacher that taught math in this way, then you know exactly what I'm talking about. All right, if the player types in an asterisk or a star, then they want to practice multiplication. So that would be the other option, and it finds the product. And so the way this runs, and I'll show you this, and this y'all can play. So it says enter plus. I want to do plus. Go down here and do it plus. Sum is 4, sum is 11, and I'm going to do some of them wrong so that you'll see what it does. Let's do that one wrong. We'll do this one right. It's going to do as many cards as were dealt. What was that, 22? 26. All right, so the way that it works is going to tell them, it's going to count how many they get right, it's going to count how many they did. So, and it'll work both ways. So this one works, and I hope it'll inspire you to do a math game. The last thing I want to show you before I hush and we close out for today is I built all these into a project in JGrass. So I want y'all to notice over here on the left side, you can make a project in JGrass by doing project up here, new. And all of my files, even though they're different games, the Go Fish game, the Math is Fun game, the setup for 4 players, all of this is in one project. But here's what I think is cool that this will do in its graphic. And we probably looked at this maybe with the animals. Can y'all see this, Mr. Schultz?
Yeah.
Okay, so since this is in a project, it will show you the association of the different files. Card, remember, was our basic class that has the attributes for a card, and the deck is built off of the cards and all of these other things, and it tells you the ones that have main methods. So some of you have probably used BlueJ, you may use JGrasp, and you may use that. If things are in a project, it'll begin to unpack those. And another thing that you also saw while I was here, maybe if I click on one of these, it'll show you the methods that are available to you in these different classes. So play around with that with the files that you have here. Okay, take it away, Mr. Schultz.
Okay,
That's enough to
jumping
be
back.
dangerous with all these cards. So
Boy, you have
hopefully
been
y'all play with one.
you have been busy.
Well,
I definitely drew the I definitely drew the easier card game to
Go
code.
Fish began to get really complicated as I started coding it. Made me wonder how these people code poker online and
Yeah,
stuff. Dang.
there's what it when you take on a project like that, it makes you realize how much goes into some of these other things that you see, especially with the graphics and things like that. So okay, so just a quick debrief about algorithms. There are standard ArrayList algorithms that utilize traversals to do a variety of different things. We can insert elements, delete elements. We can add, we can apply the same standard algorithms that are used with 1D arrays. So make sure you take a look at topic 6.4, which was covered on April 9th in our live lesson. Some algorithms require multiple string array or ArrayList objects to be traversed simultaneously. So, I mean, some of the things we've looked at, you know, the math game, we were traversing multiple array lists at the same time. A two-way selection is written when there are two sets of statements, one to be executed when the Boolean condition is true and the other set for when the Boolean condition is false. So that's kind of an essential knowledge point. And then here is our tip of the day. What we suggest, again, because this kind of fits with our game theme, we'd like you to go back and revisit token pass, which was in the 2013 exam. It was free response question number 2, and we've already looked at it. If you remember, if you've been following all the lessons we've done, we've seen token pass before. But it's a fun game to code. It's another one that's a great practice from both the array and ArrayList standpoint and from the methods and control structures standpoint. But see if you can brainstorm another method for the token pass scenario and then write the method implementation of your idea. Make notes about the purpose, the function, and kind of be thinking along the lines, you know, maybe about thinking about it as kind of an open-ended question. You know, we still don't know a lot about what the open-ended questions look like, but if you start thinking about and asking yourself questions, challenge yourself to come up with your own methods and then write out some notes about what the purpose, the function, and what the outputs would be. Okay, and then you can also take a look at the scoring guidelines out on the AP Computer Science A exam page for Token Pass.
Yeah, and by the way, I think we covered Token Pass on April the 6th based
Oh,
on
okay.
my little handy dandy notebook. So
Okay.
if you want to revisit that, check on the 6th and the 7th. I think it was the end of the 6th, beginning of the 7th.
Okay.
Maybe.
I'm guessing your notes are probably correct. Like I
You
said,
never know.
you are like the note queen. Okay, so for today's power up, make sure you're taking a look at the lesson resources from the CED. We've already talked about writing pseudocode for a card game implementation using your deck class and the array list. Take a look at some of the other things that are listed as far as the other skills that are required. Write program code to create, traverse, and manipulate elements. Explain the result of program code changes and some different things like that. Make sure you consider uses of if and if else statements and deal random cards. Try a variety of different things. Okay,
Yeah, take our
basically
code
just take
and
these
mess it
ideas and
up,
have some fun with them. Go out
make a
and see
new
if you can
game.
change the war game to actually simulate the actual war conditions that you would play under the game. I mean, have fun with some of this stuff.
Yeah.
We have some CSA show and share. We have Venus from Crawfordsville, Indiana, and we have Bentley from Highlands Ranch, Colorado. And we have this beautiful painting from, and I'm afraid I'm going to mispronounce the name, but I believe it's Syojin.
Not pretty.
Yeah, that's beautiful. It looks like cherry blossoms.
I think so.
Yeah.
It's beautiful.
So if you're watching, thank you for sharing with us. That's really beautiful. Again, keep all the pictures of your pets and your artwork and your music clips and all those great things coming. We love seeing those. You want to take us home here at the end?
Yeah. So remember to turn in your tech need, cb.org/tech, and let them know what you need of them. And we appreciate you watching. We kept you a little bit over, but it's worth it. Please play around some card games and have some fun and make something that only you can create. We're
Yeah,
glad that you're with
thank you for
us.
watching. We're gonna try the add-on slide again
Yeah,
today.
well, and tomorrow we're doing Crazy Eights, so
Ooh,
it's not
yes, yeah,
Friday. Don't forget, come back
yeah,
tomorrow. We got
yep.
one more day of cards.
Yeah, definitely join us for Crazy Eights. That's another fun one
And if
to
you build
simulate.
another card game, please turn it into, what is it, My Two Bits. Show us what you made, and we'll share.
Yeah, definitely. So as we go into this last slide, make sure you subscribe to the videos. Feel free to click the button to go on to the next video if you're watching one that you've already watched, or go back to the playlist. Have a great evening. Thanks for joining us today, and we'll see you tomorrow.
Bye.